Hey there. Welcome to the video. Today, we're diving into an essential concept in computer science. Stacks. Imagine a stack of plates in a cafeteria. You add and remove plates from the top. Well, that's the basic idea behind a stack in data structures. A stack is a linear data structure that follows the last in first out (LIFO) principle. It's like a collection of elements, where the last element added is the first one to be removed. There are two main approaches: contiguous implementation and linked implementation. We'll explore both methods to give you a clear understanding of how stacks work and how they can be applied. Contiguous implementation. Create stack. Declare an array and an integer variable to keep track of the top of the stack. Push operation. To add an item, increment the top index and place the item in the array at that index. Pop operation. To remove an item, access the item at the top index, decrement the top index, and return the item. Peek operation. To see the top item without removing it, simply return the item at the top index. Linked implementation. In the linked implementation, we use a node class to create a stack. Node class contains with a value and a pointer to the next node. Then we can implement the methods using that node class. Here's how it works. Node class. You can see in the node class, there is a variable called entry and a pointer next, to the next node. Create stack in here, declare a top pointer and initially equals to null. Also declare a counter variable for counting the elements in the stack. Is stack empty? This method can be used for check if the stack is empty or not. This is push operation. Firstly, we have to create a new node. Then check if it is null or not. If null, that means heap is overflow. We can't create more nodes. If not, we can create new node and enter our values to the stack and make the connection between nodes. Pop operation. In pop operation, first we have to check if stack is empty or not. After that, the top value should be returned and the count is decreased by 1. Peek. This is mostly like the pop operation. But here we didn't remove the values. Only look at them and get the values. As previous case, firstly we have to check stack is empty or not. If it is not empty, it return the top node entry value. That's how the peek operation works. Let's imagine we are managing a print job queue in a busy office. This scenario illustrates how a stack can be used in a real-world context. Adding print jobs. Push operation. As employees submit print jobs to the office printer, we have to place each job request on top of the print job stack. The most recent job is on the top, and older jobs are below. Printing the jobs. Pop operation. When the printer is ready, it starts printing the job at the top of the stack. The most recent one. Once the job is printed, it's removed from the stack. This ensures that jobs are printed in the order they were submitted, with the newest job getting printed first. Handling interruptions. Peek operation. Now, suppose a high-priority print job arrives while the printer is already printing. We can quickly check the top job on the stack without removing it to see what's currently being printed. This allows us to decide whether to let the current job finish or temporarily pause it to print the urgent job. Completing the queue. As each job is printed and removed from the stack, the next job in line becomes the new top of the stack. This process continues until the stack is empty, indicating that all print jobs have been processed. In this example, the stack mimics the behavior of a print job queue. The most recent job is prioritized, just like in a last in first out (LIFO) stack. As you can see, the stack concept isn't limited to software algorithms. It's an intuitive way to manage tasks in various real-world scenarios, ensuring efficient and organized processing. So, I hope you gained a good understanding about stack. Thank you for watching the video.